And your warm-up today asks you to spend about 2 minutes and basically kind of synthesize or put together, summarize what I asked you to do for homework last night. If you remember, I asked you to go home and do a little research if you could. That could be talk to someone, that could be look it up, that could be do some reading, whatever. But figure out the scientific perspective of how the Earth first formed. And that's what I want you to write about this morning. So take 2 minutes in a quick write. Have you guys done quick writes before? Okay. If you haven't, the rules for them I tried to put up there, but it means you get 2 minutes and you can't do anything but write. If you get stuck on a word or you can't even think of your first word, you just write one word over and over and over again until you think of your next word. So if you're in the middle of a sentence and you can't think of the next word to write, you just keep writing the last word you wrote until you think of the next word. So your pencil never gets to, or pen never gets to stop moving, basically. You got to keep writing the whole time. If that means you get stuck, you just keep writing until you think of the thing you come up with next. But the one today focused on how science explains the creation of the Earth. Remember, that's different. I understand that's different than how you may feel about the creation of the Earth and how I may feel about the creation of the Earth. But since it's science class, I got to teach you the science end of stuff, right? We talked about that. So just be aware that that's where we're headed today. So on the list of stuff to do today, we've got work to do. One thing we're going to do to start off today is show some people how to turn in stuff on Google Classroom, because some people forgot that, and I had to email parents, and then parents email me, and they're very concerned about stuff. So I still have 8 of you that haven't turned stuff in, Mr. Van Manen, on Google Classroom yet, that need to. I'll show you how to do that here today. For those of you guys that are done and have it turned in, which is 21 of you, you'll have a couple minutes to just hang out as I help those 8 people, just in case they got it done and they've forgotten to turn it in. I'll help those 8 people out, and then we'll get to doing the next thing on our list, which is getting your notebook set up to take notes today. I'll show you how to do that, what I want your pages to look like. Are there any folks in here that are in the Avid class? Okay. So, perfect. You guys are going to kind of be ahead of the game a little bit because you got the stuff we're going to need already. Then we've got some notes to take, and what I'm going to do right at the start is grade your interactive notebook cover. That was the first thing we said we were going to put in there for a grade. So would you flip your notebook open for me to the score sheet you've got on the back of your front page there? And all I'm asking you to do, so would you guys please find page number 4 in your interactive notebook? It should be the one right next to where we did the quick write this morning. Yes, ma'am. Say it one more time. Oh, yeah. Everything in this class is Cornell notes. Every single thing. We're going to do them. So on page 4 in your notebook, we have 2 Avid students in here, right? All right. Those 2 will kind of be your resource if you get confused, and myself. They've got pieces of paper for this from their Avid elective teacher. You don't have pieces of paper for this. So what I'm about to do is for those of you that don't have pieces of paper like they do. If they're nice enough and you sit by them, they might give you a piece of paper. Maybe they'll trade you one for a stick of gum or $1, of which I get 10% of all transactions that take place within my classroom and stuff. And I keep track of that stuff, so don't forget it. And the rest of you guys and I are going to set up your page 4 like we are going to set up all of our notes. And then I'll show you examples of stuff. I'll show you how we're going to take notes. And we're taking notes today on how Earth first formed. So that's our plan today. Good for you guys? Spectacular. All right. So your page 4 is going... Ooh, and this reminds me. Somebody in here yesterday or the day before or whatever accidentally took one of my packs of colored pencils. So if you have a pack of colored pencils today that you didn't have a couple days ago, no harm, no foul. Just give it back to me, because I had 8 of these, and that's enough for 1 per table, and now I'm down to 7. So that means 1 table has to go without. So if you found yourself with one of these accidentally, would you please give it back to me today, so that I've got enough for every one of my groups to do their thing. Please and thank you. 1, 2, 3, 4, 5, 6. Yeah, still have 7. Okay. So on your paper, first thing, we're going to do this with every single time we take notes, is the top corner right here. You can see I put this little box in there for you. you're going to make a little box, and that's going to be the topic of the notes. If you're doing it the average style way, you can see there's a spot for where it says topic on yours. So topic today is Earth formation, or formation of Earth. We put it in the same spot every day, the same way every day, so that as you flip through your notebooks, you know where to look. You don't have to read through your notes to figure out what the notes are about. You've got a little topic written right there. So it's an organizational piece. So right here, we want formation of Earth, or right there. Wherever you put it in the same place every single time. Good to go? All right. Hey. Thanks, sir. What's that? Gotcha.
Yeah.
So, Leila? Terrible. Could you help me with that name again?
It's
Leila. Okay, sorry.
It's okay.
All right, so we've got the formation of Earth up here. Everybody's got that taken care of. The next thing you'll see down on yours, it's going to say essential question. You guys can just, you know how you've got that big blank white space at the top of your notes? And then there's the first blue line. Right on the first blue line, the top of the first blue line, you're going to write EQ. And that stands for essential question. And I'm going to move this so it can get my face with any luck. Okay, I was just checking. So the essential question is what's going to go here. And whenever you guys come into the class, your essential question will be right here. It's the EQ. So the essential question, I'll tell you what it means and how to use it here in a second. But what you need to write down is this for your essential question. How did the Earth form? That is your essential question. So that goes right on that top blue line right there. There's a purpose for having that there. And, well, there's two purposes for having that there. The big one for me, though, is that I've got ADD, and sometimes I tend to, talk about something that's somewhat related, but not super related to what we're doing. Like, I'll get a thought and just kind of process it out loud. And the essential question tells you if that thought is important for you to write down or not. If what I'm talking about or what we're doing doesn't help you understand or answer this question, then it's not something you got to write down. It's the simple fact of it. This is the lens through which you should take all your notes. If it doesn't help you answer this question, if it's not related to this question, then you don't need to write it down. If it is, then it gets written down. Did you have a question or were you stretching? I'll take that as a stretching. Okay. So now we've got the topic up here. We've got the essential question here, and that changes each day we do notes. Next thing we're going to do in the other top corner, we're going to put a little code. Today's code is 211. I will tell you what that means a little later down the road today. But we'll always have a code that we're going to put on these papers. It'll always be numbers like that. So 211 is the code today. Next thing, we're making it look like this. You're taking right below your essential question here, and you're drawing a line down to almost the bottom. You want to leave like maybe 3 or 4 of the lines at the bottom, not with this line through them. So you draw it down like 3 or so to the bottom, and then draw a line across like that. Yep. So going about a quarter of the way over here on your sheet, a line going down straight enough is straight enough. If you don't have a ruler or like the edge of something, like close is good enough. And same thing going this way. Save about 3 or 4 lines down here to write on. So now that we got that set up, this biggest area that you've got here is where you're going to take your notes. So this is where everything goes that we're writing down. So the notes that we take are totally your notes. Things change in high school a little bit. And I don't know how you guys did notes before, but if you relate to what I did, it was like the teacher put it up on the board and I wrote it down word for word. And I don't know if that's how it's still done in middle school, but that's how I did it when I was in middle school. Things change a little bit here with this style of notes, in that if you're doing it that way, you're doing it wrong. You do not want to write down what I put up there word for word, because that doesn't work. The research that has been done on this, the research I've read on this, shows that just copying down what I've got is an ineffective way to take notes. it's important that when I put notes up there, you guys process it in your head first, come up with a way to summarize it, which means shorten it but still keep the essential meaning of it, and then write it down in your words. In some cases, like definitions, whatever, you get my definition, we're fine. But if we're talking about ideas and concepts, shorten it, keep the main idea of it, and put it in your words. That's important. That's one of the key pieces that changes these notes from just regular notes that you take in a normal class to notes that are more effective and work better. The other part about them being your notes is that if I've got stuff up here that you're already aware of or that you're already like 10 out of 10 on, like, yep, know that, already got it, you do not need then to write it down again. If you know it, they're your notes. I'll take your word for it. If you say you know it, don't put it down. Because these need to be yours. They need to work for you to study off of. And spending time writing stuff down you already know isn't going to be super helpful. So shorten stuff. Only write down things you need to know are kind of the two key components or two of the three key components. The third being, when it comes time to write stuff down, you've got to figure out a system that works for you that shortens the amount of time you spend writing and maximizes the amount of time you can spend listening to what I say or any teacher says. So sometimes that means shortening words, like instead of writing out long words, you abbreviate them. Sometimes that means if there are words that we're using a lot, like the word the, or the word change, or the word temperature, you can come up with symbols to represent them. Like instead of writing a word 1,000 times, you can just write a triangle, so you don't have to write that word 1,000 times or something like that. But we're looking for a way that you can minimize the amount of time you spend writing, but still maximize the amount of information you get down, while maximizing the amount of time you can pay attention to what I'm saying. So minimize writing time, maximize information, maximize listening to me or any teacher as we go over this. Those are kind of the key components of this. Good there? Okay. And the questions we'll talk about a little bit later. This section, the summary section down here, we'll talk about a little bit later. And then when you're all done with this, I don't know if this thing's going to follow me around or not. When you're all done with this thing, you're going to have notes in a notebook that wind up looking like this. You can see she's got the same setup that you do, and this is how her notes look when it's all said and done. This is what you guys should be shooting for when yours is all said and done. You can see there's lots of color on here. I'll tell you, like, specific color means specific stuff, underlines, highlights, and all that. So everything means something specific on here, and I'll teach you how to make yours look like that. And these count for, Nate, when you guys do the Cornell notes, when she does the binder checks and stuff, you're good to go.
How old was that book?
Last year. So this is 1 year. I just grabbed like 10 or so random students last year, and this is just one of the ones. But that's what it's going to look like when you guys are said and done. Fair enough?
Yeah.
Wonderful. All right, so with that said, we are going... Here, those mine. So with that said, we're going to start taking our notes today on the formation of Earth, right? On how it formed. You guys ready for it? Perfect. All right. So all you need to be is on that page, page 4 in your interactive notebook. And I'm going to take care of, let's see, the note stuff right here. We're actually going to start right there. And probably, let's do it like that as best we can. And then I'll close some of these shades because it starts to get hard to see stuff, and I didn't think about that in time. You guys see it all right now? Perfect. So, what you're looking at here is, number one, it seems unreal, like somebody made this or somebody created it, or it's fictional. This is real. These are all real images taken from satellites in space, looking out into space for very long periods of time to capture this light. These are called, individually they're called nebula. When you talk about it in a group, it's nebulae, but these are nebula, and these are how we predict our Earth started. This is how we think we came to be, was from one of these. These things are gigantic clouds of dust and gas. And when I say gigantic, I don't mean like the size of Oregon gigantic. I don't even mean like the size of the sun gigantic. I mean like can't process it gigantic. So to give you an example of what I'm talking about, I've got to use somewhat of an analogy here. You know how when you go to a fireworks show and a firework goes up in the air and explodes and you see it and then it takes a couple seconds for the sound to get to you? Yeah. Or alternatively, when there's like a lightning storm and you see a lightning bolt go off and then you count like 15 seconds and you hear the thunder. And the more time there is between the seeing it and hearing it, the further away the thing is, right? So light does the same thing. Sound travels at something like 347 meters per second. Light travels at something like, it's 197, forgetting this, 147,000 miles per second is how fast light travels. So it's like 6 times around the Earth in a second at the equator is about how fast it really goes. This distance is so far, right? Think about the firework thing here, that if a star lit up over here, or if a star blew up over here, or if something happened to a star over here, it would take somewhere in the neighborhood of 100 million plus years for the people or the things over here to recognize that that light had like shone on. It would take 100,000 years for the light to go from here to here, is how big that thing is. It's huge. It takes from the sun to us, which is a huge distance, right? 7 minutes for it to go from the sun to us. We're talking like if we are over here on this like pretend Earth that I'm putting right here, and there's another star over here that blows up, you would never know it. Your kids would never know it. Your grandkids would never know it. And like 100 million years of people later would never know that that happened until it finally got to them. That's how big these are. That's how big this thing is. These nebula are called like star nurseries because this is where stars and planets are born from. And we predict this to be true because we can look in these things and see these processes happening in them. So it's not like as we talk about this, scientists have been able to go back in time and see like, oh, here is how the Earth formed. Like we know how it happened because we can see it happen. We base our assumption on how the Earth formed on what we see happening in the other nebulas that are far away, right? And it's just like other science. At one point in time, science people thought that the Earth was the center of our solar system, right? But it's not. We know that now. What has allowed us to kind of modify our scientific ideas as time has gone by? What allows us to fix misconceptions like that in science? Exploring. Yeah, basically like technology, exploring technology and stuff like that. We thought we were the center until we had technology that could prove that we weren't. We think this is how this stuff happens until maybe we develop technology that either A, confirms it, or B, proves it untrue. But at this point, with the technology we've got, we think this is how this happens. These things are actually quite cool. This one is a different one. This is called a planetary nebula. This is what happens when a smaller star like finally dies. But these two, this is called the Eagle Nebula. This is a very famous one. And I don't know the name of this one, perhaps the Crab Nebula. But these things are out there. And in those clouds of dust and gas, stuff is moving around. Stuff is swirling inside these clouds of dust and gas. Mostly hydrogen and helium is what the gas is. And then other elements that were formed in supernovas or during the Big Bang or whatever are also part of it. But this is where we began, and these are called nebulas. So I'm going to take you through the process of how we think a nebula goes from a big, gigantic cloud of dust and gas into something like our solar system. And not only that, but are you guys familiar with the concept of conservation of matter? Remember do you know the law of conservation of matter? But it can be, thank you, transform, change, yeah. So apply that for 1 second to you, right? Are you made of matter? Yeah, if you're not, we've got a serious issue with perception going on. So you are made of matter, And your matter cannot be created. It can't be destroyed. It can only be transformed, right? If that's true, and we're talking at the atomic level here, if that's true, how long have the atoms that make you been around? Forever, right? Have the atoms that make you, that have been around forever, have they been just waiting on you to get here and then they turn into you? Or have they been doing other stuff for the last couple billion years waiting for you? They're doing other stuff, right? Other stuff including going through this process. If the atoms inside of you could express or talk or say something, they could talk to you about what this was like. Because literally, in the most literal sense of the word, your body has been through this process that we're going to talk about today. Because it's been through this process, it's been through the creation of the universe, however that happened, the atoms that make you up have been through and seen that. The things that you can touch and feel in your body have done this stuff. And one gross point I'll make about that, if that's true, if the things that are in you have been around and doing other stuff since 13 and a half billion years ago, what other things have they been doing? Any ideas? What have your atoms been doing while they've been waiting for it? Say it again.
Other humans?
They probably have been in other humans. They have probably been in dinosaurs. Or they could be, right? They could have been a part of dinosaurs at some point in time. They certainly have been a part of other living things, because in order for it to get in you, you've got to eat it for the most part, or drink it. So they've been the atoms that make you up have been other things before. They've been living things before. They've been through this process before. So think about this is what I was talking about when I said it's going to get gross a little bit. Say you have spinach for lunch today, right? Or some kind of vegetable for lunch today. What do they spread on vegetable fields to make it grow faster? Not just chemicals, but feces or manure. That's right. So the atoms that you've got inside of that vegetable you're going to eat at lunch or whatever today are only really one step removed from being poop. So basically, you're eating you're one step away from eating a poo, because they spread the poo on the field. The plant absorbs the atoms from the poo, turns it into stuff that tastes yummy to you, and then you eat it. So it rearranges them and turns yucky poo into yummy spinach, and you eat it. And you're like, oh, that's so gross. I'm glad I don't eat spinach. But then you eat meat. So let's say you eat a cow. Well, then you're 2 steps from eating poo, because the poo turns into the grass that the cow eats the grass, you eat the cow. You're only 2 steps away from being a poo eater. And then the other gross part is you're like, well, at least he's not going to ruin that clean, fresh bottle of spring water that I paid $2 for. Well, law of conservation of matter, can't be created or destroyed. Chances are that water you drink, someone else has already done that before. Someone's drank it, someone's used it, someone's got rid of it, and if not someone, then something has done that. Granted, it's refreshed and clean when it does that, but it's already been in. The atoms that you drink in from that water have already been in and out, sometimes multiple times, of other people or other things. So you've got that to look forward to. As you're eating your lunch today, just think how many steps away am I from eating an actual poo? Because you're not very far away. The atoms you're eating are only 2 things ago were in a poo. So you're welcome. Enjoy your lunch. So the reason I bring that up is because all those atoms that are here on Earth now and that have ever been here or that ever will be here have gone through this process. So now we'll talk about what that process looks like and how it goes. So we're starting right here. Here's another picture of a nebula. This is the Eagle Nebula. And again, it looks relatively small, but this is hundreds of light years across. Right? Something happens over here light-wise, and it takes 100+ years for it to get over there for people to see it. So the theory we're going to talk about, the first thing you want to get down today is the name of this theory, which is called the nebular hypothesis. That's the name of it. Because it deals with nebulas, and it talks about how a nebula got turned into all this stuff we see around us here. So what's going to pop up now is a big block of text, That is like 2/3 of the nebular hypothesis. And this is where I'll go back to say, like, it's important to me that you get down this stuff up here, but not word for word. Because if you do this word for word, we're never going to get to move on. It'll take forever to get stuff down. So read it, process it, come up with a short way to write it, and get it in your notes. But it says this, that our Earth is about 4.5 billion years old, and that it formed from, I think yesterday somebody called it stardust, and that's basically right. Our Earth formed from the nebula, cosmic dust. There is hydrogen, there is helium, and there are other solids and other gases inside of there that make up that cosmic dust. Where could you look, as a side note, where could you look to find the list of stuff that may or may not be in a nebula? Nope. There's a list of it in here. Yeah, that's the stuff that's in there. Inside that nebula are mostly hydrogen and helium, but also trace amounts of everything up to like iron. Anything after iron is created, well, I guess that's in there too. But everything after iron is created when like a supernova happens, because it's too heavy. So, in that cloud of dust and gas that we've talked about, it is spinning, it's moving, and there are things bumping around in there, if you could picture that, right? Things are moving around. And because all those atoms are moving around, they're like bumping into each other, running into each other. And what they do when they run into each other, it's called accretion. And we'll talk about that in a second. So it says, through accretion, planetesimals formed, which turned into everything we see today. We'll talk about what accretion is here with the next note that pops up, because it's the definition of the word accretion. So definition for accretion that you want down is this, and I can make it make even more sense for you. Accretion is a verb, so it's an action word, and it is the process or the action of small particles colliding and then sticking together when they do. So that's definitely a definition you'd want down in there. And as you guys are writing that down, when you're done writing it down, I'm going to have you close your eyes and picture something. There we go. The bigger and bigger you are in that scenario in your head, the more likely you are to stick to stuff, and then as a result of that, the faster you would grow, right? That's what happened in our solar system with accretion. You could also picture it like this. If you took like 1,000 little dots of Play-Doh and sprinkled them on your desk, right? Those could represent the atoms in the nebula. And you grab one of them and start moving it around. Once it touches others, it's going to grow in size, right? It's going to pick them up and get bigger. That's what happened. Those things were moving around in there, touched other ones, and started growing bigger and bigger and bigger. The big things, what's the biggest thing in our solar system? I'll ask it again. What's the biggest thing in our solar system? Thank you. Yeah, the sun. The sun was the thing that got big fastest because it got big first, which means that it started bumping into other stuff more often and started collecting stuff faster and faster and faster. But that's the process. It's called accretion. It's like starting with a snowball at the top of the hill and rolling it down, and as it goes down, it grows bigger and bigger and bigger all the way down. That's this process. Those tiny little atoms stuck together and over time got bigger and bigger and bigger and formed into the things that we know. Here's the other 1/3 of this. So as those things grew, some of them got large enough to have like gravity, and enough gravity to like pull stuff to them. Because you've got gravity, you just have very minor amounts of it. You need, like, the more mass you have, the more gravity you have. So eventually, some of the objects out there began to have a significant amount of gravity. And as they did that, they started to attract more and more particles, and they became our next vocab word, which is the word planetesimal. And planetesimals are to planets like Cheerios are to donuts. Figure that one out. How are Cheerios related to donuts? It has nothing to do with the hole. It has nothing to do with the circle. It has nothing to do with the taste. Yeah.
Oh, okay. They're like miniature of them.
Yeah. So literally, and True fact, you can look it up on Wikipedia. Cheerios are donut seeds, if you didn't know that. You can take a Cheerio, true thing, don't give me that look, because I know what you're thinking, you got to try it out. Yeah, you put Cheerios in the ground, you water them, you give them the tender loving care under like a light, and you sing to them every night, and you read them stories. And after 3 months and 6 or 7, I think it's 7 days, they turn into donuts. So all those people say, oh, we're going to the donut shop and cook donuts. No, they don't. They grow donuts. It's like an adult secret. When you turn 18, there's this whole book of secrets you get, like things only adults know. That's one of them. That donuts actually come from Cheerios planted in the ground, sung to, read to, and grown under light, watered with love and care. So just like Cheerios are donut seeds, like Cheerios turn into donuts, planetesimals are planet seeds is the idea behind it. Planetesimals start off as little, like tiny planets, like we're talking small, like softball-sized things and smaller, that can turn into planets. All the planets that we have in our solar system, the sun included, started off as a planetesimal, a small thing that grew to the size that it is now. Some planetesimals did not make it to like planet size. Those things turned into like asteroids, comets, and things like that we see. Here's your definition for the word planetesimals. Planetesimals are small objects formed through that process of accretion that we talked about that are likely to form planets or other things that you see out there in space. And that's how we think we form. We had a nebula. It's spinning and swirling. Accretion occurs and starts to form little solid objects in this nebula. And as those solid objects form, they're starting to get bigger and bigger. And eventually, they suck up all the dust and gas that are around them in those other nebulas that you see and turn into the planets that you can see right now. All the way from the sun out to our very last planet, which at this point in time we think of as... What's our last planet? Gross. What? I don't know. I think it's Pluto, isn't it? It's a dwarf planet. So, with that, that's the end of what we got for our notes today. I'm going to have you leave them out, but we're done writing in your notes today. As you do that, please reflect and make sure that you haven't written down exactly what it says, that you've summarized it in your own words. Say it again. No, we're about to do something right here, right now. So, yep, we're writing. So, with those notes, there's a couple things you got to know. What to do over here, what to do down here, and what those numbers mean. So we're going to do this stuff together. The questions, that little space you reserved right there, is for questions that you're about to write. I'm going to help you write these. And they're not just random questions. They're questions that you predict, based on the notes we took, I would ask you on the test. So they shouldn't just be like, oh, I need to get 3 questions down, I'll just write 3 questions and be done with it. Process it, think about it, because you want your questions over here to show up on my test. Because if the questions you write here show up on my test, you know what's on my test, right? So get good at this. The level, or the code you put up here, 211, is going to tell us how complex your questions have to be. The first number is the least complex style of questions, called the level 1 question. And you'll always see this up here for you guys. So you see how it's 211? We're going to have 2 level 1 questions, which are the simplest, 1 level 2 question, which is the mediumest, and then 1 level 3 question, which is the most complex. So I'll walk you through what these are like. So these questions get written here, though, and they should predict what I'm going to put on the test, and they should be answered by your notes right there. So level 1 questions are like what question? What is the definition of, or who is the person that did this? But they're questions that are like recall questions, where you don't have to explain anything. You can just say a word or say something you've memorized for an answer. Based on that, we've got to come up with 2 level 1 questions you guys think you'd see on the test. With that understanding of what a level 1 question is, with a hand, if you don't mind, does anybody have a level 1 question they think we can go with? Yes, ma'am. There we go. So there's one, and I guarantee you that one's on the test. So one level 1 question that we all need to have down is, what is accretion? That's a level 1 question because it's a definition. It's just remembering the definition of it. So what is accretion is a good level 1 question. Hey, Lonnie?
Well, level 1 would be what is a nebula, but also could be what is a nebula and what
Yeah, you could do that. You could have what is a nebula in there if you can find that in your notes, whatever. We can get some other examples, but what is a nebula is a level 1 question. Yes, ma'am?
what is planetesimal?
Yeah. What is a planetesimal is a level 1 question. So any definition is a level 1 question. I can tell you that both of those are on this test. So it would be a good thing to have in there. I can guarantee you those are on there. Any other level 1s you can think of?
Explain the nebula hypothesis.
Explain is a level 2 because that's not like a memorize. That's like explain how it all fits together. So another level 1?
What is the nebula made of?
Sure. What's a nebula made of? You could say, to turn your level 2 question into a level 1 question, you could have what is the nebular hypothesis, and then it's a memory thing, like you just say what the hypothesis is. So all you need is 2 level 1 questions on there. 2 of those questions that we just came up with need to be included on there. The next one we've got is 1 level 2 question. Level 2 questions like how questions or explain the connection between, describe, those are good like level 2 words. And if you ever get lost for like level 1, level 2 stuff, I've got a poster here with like level 1 words, level 2, level 3 questions you can ask. What's a level 2 question? Come up with.
Explain how accretion and planetesimals together.
That's a great one. Explain how accretion and planetesimals are linked. Explain how one is related to another. That's a very good one. Yes, ma'am. Perfect. Explain the nebular hypothesis. Very good.
Explain through what process I can explain.
That's probably, so depends on how you answer that. If your answer to that question is through the nebular hypothesis, then that's a level 1 question. If you explain it as in like you take me through the whole process of stuff spinning around, then that's a level 2. So that one kind of depends on how you answer it. So those are level 2. You got one more?
No,
Oh, yeah. Nope. So it always goes in order. This is level 1, level 2, level 3. So you need 2 level 1s, a level 2, and a level 3. So level 3 questions, the last ones we got on there, are questions that are like predictive in nature. So they are like, based on what you know, write a question that kind of goes along. So what I'm talking about there is you could say like, predict what would happen, for example, if Earth got bigger faster than the sun. Because clearly the sun got bigger faster than us. That's why we rotated around it, not it around us. Predict what would happen if the Earth got bigger before the sun got bigger. What would be different in our solar system? Because that means that's like a deep level of question you got to process. Because that would change like what orbits around what. The Earth actually wouldn't be the Earth anymore. We'd be really hot. We'd actually be the sun, and something else would be the Earth. Yes, sir.
I would say, wouldn't we have less heat?
We'd have.
Sun would be level 1.
So if we were bigger, faster, we would actually be the sun. So the thing that gets the biggest, the fastest in solar systems winds up being the sun, and everything else just kind of spreads out from there, we think. So those are the questions, and then down at the bottom here, there's a spot you guys saved for answers. It says summary if you're in the Avid class, but if you're not, it says answers. And really, it's not a summary. In this section down here, you are answering this question, the essential question that we've written up here, and the today 4 questions that we've written here, get answered down here in like 2 or 3 sentences. That's all it takes. 2 or 3 sentences down here, and those are the answers. Inside your notes, your homework, I should say this, your homework is often to write the questions, do the summary, and handle your notes like we're about to do. So most of the time you'll get a code like this to put on there, and that means when you go home tonight, here's what you got to do. Write this many questions, answer them, and you're good to go. The other thing you got to do to your notes is you need to keep them like this. You can see that she's got color on hers and everything's highlighted. So in your notes, if you don't have highlighters, that's fine. You can either highlight or underline and circle. But vocab words like these two should be a specific color all year long. So maybe you make your vocab words green and highlight them green with their definitions. And then key points like key knowledge, when we talked about what the theory is, should be a different color. If you don't have highlighters, you can use circles and underlines for the same thing. Just be sure that you're doing it the same way all along. So your homework tonight, when you guys come in next class, is you get the questions and answers done and have your notes like edited is what I call it, which means they're highlighted or underlined and circled when you guys come back in next time. Make sense for you? All right. So once you're there, we don't need to wait for the bell. We can pack up and we can head to